listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
All right. That's my inner Matthew McConaughey here. And Kent has got to be a fan. I think he's from Texas. I'm not sure. But welcome to Making Data Simple. I am joined by Kent Collins, who is a solutions architect at BNSF Railway. I just did a panel with Kent in Charlotte not too long ago. I guess it was June, at the IDUG International DB2 User Group, North America. We talked about evolving technology, professional roles, business opportunities, and I will say I think it's the first time that I've been heckled on stage by the person that's on stage. That's Kent. But it was fun. It was fun. That what that did is keep it real, right? No, I love Kent. He's a data guy at the core, at least I think he is. And we'll talk about a whole bunch of things, but and like I'm an AI guy as well, but it all starts with data. So let me give you one last lead in, and then I'll let you introduce yourself, Kent. I saw this on your LinkedIn page, and I think it defines you well. You said, as we move into an era where data is an asset, I want to help companies discover new data pathways which add significant knowledge they can use to compete and win. So I think that describes you well, at least. And it's data. It's close to my heart. So welcome. Thank you for being here.
Thank you for having me.
So let me, that was my introduction. I like I do as always. I'd like for you to introduce yourself. Tell us about what you do.
Well, I'm Kent Collins. I have been in this particular field for many, many, many years. But I started in 1977 working on mainframes, IBM mainframes, 158, and started on working on the really, really large stuff when the console was paper and green bar paper, and you had to keep putting it in, and ran around as a tape monkey and mounting tapes all the time. So
you don't look like a day over 40, Kent.
Oh, okay. So checks in the mail. Yeah. So I been doing it a long time, but data, having worked as a system administrator, having worked as an architect, a Java architect, having done application support work, worked for really, really large companies. A lot of them. I've had a chance to go pretty much work in all the disciplines in IT. Started with DB2 in 1984, man. I still remember my visits with Don Hatterley and sitting. I mean, Mr. AI thinks that I was kind of off the board there a little bit in our first meeting at IDA. Mr. Hatterley with that funny looking hat and sitting on the other end of the table and having dinner with me. I wanted to know when Z was going to run on Windows platform, and I wanted to know all kinds of stuff when I was younger. So I'm sure he was anxious to get back to his wife by the time dinner was over with.
So you're always a troublemaker. Is that what we've established here?
Hey man, when it comes to the big blue, I'm a pusher, not a sitter. So yeah, I demand a lot, and I haven't been too disappointed. So yeah, but my career goes way back. But I've been doing data work for a long time, and right now we're seeing some really interesting things take place in that arena. So I'm excited. Really excited.
Fantastic. That's what we'll talk about. Here's what I love about Kent. There's no BS. You have a frank, open conversation, and that's exactly what we'll do today. So, we're going to be talking about some data, and typically we talk about data in the context of tech companies, banks, healthcare, not always about rail transport, but I think you've got a great story here. And the one thing I'll start off with, I think, is an interesting story, since I think you've got an affiliation with Mr. Buffett. I'm sure you maybe you get tired of hearing that, but I'm not sure if he's done pretty well in some of his investments. But the one story that I've always liked about Buffett is, like, in the early '90s, Bill Gates invited him to his summer home. I think it was over July 4th, and it's the first time they had met. And they sat down or whatever. I don't know how it went out, but Gates said, "Hey, you've got to get a computer." And Buffett says, "Why do I need one of those?" He said, "Well, you can keep track of your portfolio." And he says, "Well, I only own one stock. It's Berkshire Hathaway." He said, "Well, you can do your taxes." He said, "I don't have any income. Berkshire doesn't even pay a dividend." And he goes, "Well, look, it's going to change everything." He goes, "Will it change whether people or how people will chew gum?" He said, "Probably not." "Well, then I'll stick to chewing gum and you stick to your computers." But the reason I tell that story is the irony is that every company is a tech company now, namely BNSF and Kent Collins, of course. But you can't get away from technology. So let's start right there. How do you use data at BNSF?
That's a great question. I mean, you have a 160-year-old company. So,
Wow.
over time, you get people. I'll tell you, Al, something that I find extremely interesting. I've worked at a bunch of different Fortune 100 companies, really, really large companies, and BNSF is the first one I've ever worked at where I saw more retirements in the first month in IT of my employment there than I had seen in 15 years of working in IT. Most people, they work 2 years somewhere and leave, go somewhere else. They're always looking for the next hot spot or the next project, and they just kind of float around. But the people at BNSF, they love BNSF, they love the railroad business, they love working together. They create a culture in which being friends and being supportive is more important than completing a task, and that's something I'll always cherish at BNSF.
Wow.
But saying that,
it sounded like you choked up a little bit there too, man. That must be a good culture.
It is. I got a lot of good friends there, and I enjoy working there. And they're good quality people that are there. One of the things I find interesting is, when you got somebody that's been moving freight on the railroad and they're working in the field and they've been doing it for 25 or 30 years, they know better than the data. I mean, they know better than the data. No matter how much data you give them, their gut instinct is more important to them than whatever it says, whatever that number tells them, or whatever someone shows them in a set of analytics charts. They still say, no, I'm moving that train first, even though that train's going to cost me in the long run. I just know my gut tells me that train should go first. And transitioning the culture of the company more toward letting the data reveal how we should review safety, how we should review velocity on the railroad, how we should view moving freight from coast to coast. That's a tough lift. It takes everybody. It takes time to transition. And one of the things we have in our corner now that we didn't have in the past is our workforce is aging. And when your workforce is moving into the 58, 59 year age group, you realize that you're going to be replacing them with individuals that don't have that gut sense. They don't have that 35 years of knowledge that train goes first. Mm-hmm. So if we don't get our knowledge base out of the heads of those that have been moving freight into reliable systems that can help these younger people know exactly how to run freight across the railroad, then we're going to be challenged. And so that's our challenge, is to get that knowledge into systems that help people make decisions on the operation of the railroad.
Well, so how are you going about doing that today?
Well, we have several, we have lots of projects that are going on. We've got some projects in which we're taking some 20, 25-year-old applications, and we're looking at how they can be improved, and we're looking at specific business functions on things like what causes trains to be stopped and why do we stop them, and is there a way for us to use data to make better decisions about when they should be stopped. We're always safety focused as a company, so we're always looking at data, how to make sure that when our people come into work in the morning, they go home the same way they came in to their families. Mm-hmm. So, because trains can be pretty unforgiving. Mm-hmm. They're big beasts. So, so we're using data in that way. We spent probably 3 to 4 years out with a vision focus, right? I mean, we had some initiatives in which we wanted to make the data available to the business so that the business could use that data to make decisions ongoing as they're looking at the data, and that took us several years to get more access to data to the people that need to have it and be able to make those decisions. Now we're looking at, to be honest with you, data that a human being can't consume, right? I mean, you can't look at 15,000, 20,000 measurements and calculate it all in your head in real time and try to figure out what you should do. We've got to be able to provide decisions to them with good quantitative analysis and with some level of confidence that we're telling them the right thing.
So what kind of decisions, I know you're on this transformation, but what kind of decisions are you making from the data to day?
Day to day. Most of the structures and most of the things that we looked at are 20 years old. Most of the modeling techniques that are used are 20, some of them 15, 20 years old. So we need to look at how that data needs to be mapped to meet those business demands and business requirements going forward in the future. We're looking at some things as, should it be asset compliant? Should it not be asset compliant? Should it be capped? Should it be, is near real time good enough for the data for that decision? What's the right vehicle to store that data? Should it be persisted? Should it not be persisted? We're doing on-edge computing, which we weren't doing in the past, and the reason is because the bulk of information is so high. These are images that we're dealing with. We have to process them on the edge because there's not enough bandwidth to transmit them into a data center and a server and process them. So we're doing a lot of on-edge computing and finding really good results from that. We're trying to be innovative in the sense of UAVs and other forms of technology that we might use to help us observe the railroad and manage it. We're looking at building in-stream analytics into things like track analysis and whether the track needs to be replaced or not replaced. So we're always trying to look at ways to help us maintain and run the railroad in a more efficient manner. And
when you say, sounds great. I mean, when you say processing on the edge, what is the edge? What is the device in this case?
Trackside digital camera would be and some computing
so
power
you're
behind
using.
it.
Well, then are you using any AI with the visuals to map visuals to? Nice.
Yep. And that AI has helped us. Some of the first numbers and some of the first values that we've seen, it's helped us with the ability to eliminate. I mean, we're picking somewhere around 200 out of 200,000 or something photos, so we can go through them and we don't have to keep those photos because they show no interest, and so we're keeping only what we need and analyzing only what we need. So trying to make sure that our equipment continues to operate and not fail in flight and not fail and cause any form of issue. So we're always monitoring train traffic and we're always monitoring train movements and looking at the equipment individually at the individual components to try to predict any form of failure that might occur.
So do you have, no different than the airlines with jet engines, do you have IoT, essentially sensors within the engines itself that are sent it back to the data center for analysis?
Yep, the locomotives have sensors, the cars have sensors, there's sensors on the track. Yeah, I think I'm not 100% sure of this statistic, but it's one that I heard years ago when I joined the railroad, that we run the largest private network in the world. Mm-hmm. The United States government's the only one with a larger network. So we have a lot of I don't know how many miles of track, but in the close to 40,000 miles of track that we have to monitor and make sure that we're maintaining it properly and not using our manpower and using our resources wisely. So
one thing that's often the joke when you're flying now, it depends on which airline you're talking to. If you're talking to the software developers, etc., they'll say, look, the the pilot's there for your just for looks, for your safety. The plane will fly itself. Is that the same thing we're talking about in the locomotive? People get there, they look the part, and they get in there and take a nap, or what?
No, not,
No,
I
not
wouldn't,
quite.
yeah, I wouldn't say that yet, but that's something that we're always at least looking at. But no, our train crews are extremely important to the successful operation of a train. So, and so are our yard people that manage and operate and process trains as they come in and out. We couldn't move anything without those folks.
Yeah, I certainly wasn't diminishing their role in that comment. So, hey, so give me the use case though on the visualization that you talked about there. I mean, are you recording all tracks, and then to identify, tracks that need to be replaced, or I mean, give me a couple of use cases that you use that for.
So one of the successful projects that I'm a part of, just one member of a large team, is we try to use we call them geometry cars, but basically they're little small trains that collect an awful lot. They collect 93 channels of data, 93 channels of information with regards to the track, and they traverse the track 45, 50, 60 miles per hour, and they pick up these metrics, and then we process these metrics in real time. So we bring them into the center, we process them, and we try to determine if we've identified a defect that needs to be analyzed further or needs to be reviewed. So we try to identify, cracks or weak spots in track, and then we'll make a decision about whether to do a site inspection or not do a site inspection. And they cover this track several times per year. So right now, I believe we're running something in the ballpark of 4 or 5, and we're hoping to expand that number to a larger number so we can cover the tracks more frequently and get more data on the track.
Do you have like ELA that you're up against to reduce the time that trains are stopped?
I don't know if that type of information really isn't provided to me. I don't really know as far as you mean as far as scheduled trains and things like that.
Yeah, I mean just like you always have like targets, uptime for I'm in the software business, right? You talk about uptime, etc. I don't know if you have something in the railroad business, but then again, I could understand if they don't make you aware of that because you don't want to, you don't want the reap what you sow, so to speak. In other words, if the train needs to be stopped, you want it to be stopped. You don't want to encourage people not to do that when it needs to be done based on your safety focus, as you mentioned. But at the same time, I didn't know if there was objectives that you're trying to meet as you're creating these solutions.
Well, definitely, you could say one rule of thumb in building these solutions and consuming this new data is to improve the shipment velocity and the reliability of trains and not have train. I mean, the worst thing for us is to have to stop a train in transit, right? I mean, we want that train to move from point A to point B without having to be stopped and have some piece of equipment repaired. Ideally, it's sort of like your car, right? I mean, you drive it to work, you bring it home, and you park it in the garage, and then the next morning when you get up, it won't crank. Well, that's an ideal place. I mean, if you're at work and it don't crank, it's a little more inconvenient. If you're in the middle of the road because you stopped to pick up a burger, and you get out and you go to crank it and it won't crank, then you're in a lot of trouble. So the same thing's true for a train, right? We want the equipment to be repaired when it needs to be repaired, not too soon, not too often, if it doesn't need it especially. And the last thing we want is for a equipment failure to cause us a delay in the shipment. So making our customers happy, getting the freight to the customers on time and on schedule, absolutely paramount to us and to our success.
Are those trains, I mean, look, I know nothing about trains, maybe not as much as I should anyway. Are they running 24/7 for the most part? And then, scheduled downtime, once a week, twice a week, every day? I mean, how does that work?
They are. They run all the time, and they never stop. And there are many different types of trains. So if you're sitting at a sitting at a railroad crossing and you see this train come by and you see all these containers that are stacked on like what looks like a flatbed, and every one of those cars is that you see, and that's an intermodal train, what we call an intermodal train. So it's moving these boxes that get put on an 18-wheeler on a tractor trailer and then hauled to a distributor like a Walmart or Amazon or somebody, right? So that's an intermodal, and we have different kinds of yards. We have hump yards and we have mechanical yards. A hump yard is a yard that uses inertia to basically decompose a train and then recompose the trains from that set of cars. So as trains come in, they get processed. They use inertia to disconnect the cars from the train and to move them to inside tracks that are set aside for constructing the next train. And there could be 4 or 5 trains being constructed, and then they're due out to leave the yard on schedule, and there's a crew assigned to them, and away they go, moving out of the yard. And then we have mechanical ones in which there's actually an equipment piece that actually moves the car in the yard from one location to another. So, and there's maintenance facilities. Like I said, not all the facilities have maintenance. So some of them do, some of them don't. So you really want to have, a repair. You'd like to have that repair done when that car is in that yard, so you don't have to ferry it there or move it there. That's another expense that we would like to not have to have.
Which operation proves to be the most difficult? Do you have a viewpoint on that? They're all the same.
I'd say, when I first joined BNSF, I remember having a conversation with someone who I work with every day, and I said, to me, the airline industry is orders of magnitude more complex than the railroad. He quickly...
And they probably shut you down real quick, did they?
He really quickly educated me. And after the conversation, which took about an hour or so, I have to agree with him. The railroad is extremely complex. So as far as one area being more difficult than another, I'd say the most difficult task for us is to stay alert and aware, and like I said before, do our job as efficiently and effectively as we can with as much safety as we can. That's probably as difficult as any task that we actually try to undertake.
Sometimes I'll be sitting at a light or whatever, or a crossing, and I'll see the train go by, and there's a bunch of flatbeds, but there's nothing on them, and I can't help but think, oh boy, that's got to irritate the hell out of somebody, because something's messed up. Because you hardly ever see that. I mean, I got to believe that there's something messed up in the either it's going for maintenance, I don't know, you tell me, or it's something messed up in the logistics by which they're doing a lag with nothing on the train. I don't know.
Yeah, and we have a term that we call it haulage. It has to do with the fact that, and you asked me a minute ago about the most difficult task or most difficult thing to solve in the railroad, and I'll tell you what it really is. Safety is extremely important because, again, it affects us all personally. But the key to being successful at moving freight in the railroad is equipment placement, right? So if all of your equipment are next to the Mississippi River and you've got 100,000 shipments coming in to a California port, the cost to move all that equipment to the point of impact, which is the shipments coming in on the port, is extremely costly. Now you got to move all of that. So getting locomotives in the right location, getting equipment, cars in the right location, getting the stuff that you need to move things around in the yard, making sure that the maintenance facilities aren't having to have equipment sit waiting because you can't get to them because you're running 3 shifts already for repair. You need to be sure that the resources that you need to move the freight is where you really need it, so that all you have to do is just move it a little distance, and there it is. It's ready to go. And that reduces your cost and makes it more efficient.
Now I got to believe you're talking to some of that complexity that you got educated on for over an hour. Hey, All right, so some of the decisions that you're being made, you're looking at, you've got IoT devices essentially reporting back on, engine trouble, engine issues. You're looking at track that needs to be repaired or replaced. What other kind of decisions?
Wear and tear analysis is on cars, right? I mean, cars tend to, if think of it this way, if you've got several tons of merchandise that you're moving in a car, and if that car loaded always goes in the same direction, well, track isn't straight, right? Track curves. Well, you can imagine if you've got a train traveling at say 50 miles per hour as it goes around a curve, which wheels do you think are going to have the most force applied to them? So, again, it's trying to get the most mileage that we can out of the equipment before we have to start making repairs to them. And that basically means, back to what I'd said before, where is the equipment placed? What is it going to take to get it where you need it? And how many miles has it traveled since it was last reviewed for repair? How much weight has it carried? How many miles has it traveled empty? Because even traveling empty can be not dangerous, but can have a higher impact to certain areas of the car than say if it was fully loaded. But yeah, I mean, all those things are. So we're constantly looking at the cars. I mean, think of it this way too, and this is something that's interesting because I found it interesting when I joined with the railroad. Think of braking a train, stopping it, trying to bring it to a stop. So it's traveling at 50 or 60 miles per hour, and now you've got to bring it to a stop. Well, it probably wouldn't be good to have some cars stop rapidly and other cars stop slowly. It would be nice for there to be uniformity, right? Well, that's handled through the equipment. The equipment is applying the brakes to the cars in a uniform manner. So one of the groups that I work with, a really, really, really strong technical group that I'm extremely proud of, they monitor moving trains and they do it in real time. And so we process about somewhere about around 90 million to 100 million rows of data per day. So when you see it, for example, one of the analyses that this group was able to do, which was about an hour or so, maybe even 2 hours to accomplish by humans, is to determine whether it's possible that a brake may not be working for a particular wheel. So, for example, you've got a train, it's braking, it's going down an incline, and it's braking, and they have the ability using temperature to determine if maybe some of the brakes are applying completely and some of the brakes are not not actually applying. We actually call it cold wheel, but basically it's the ability to determine if maybe we need to replace and or investigate the brake for that wheel. So what we used to do is we used to just stop it and go look at every single solitary one of them. Well, that can take, like I said, the train stopped, it can take a long time to site inspect every one of them. And now we're working on some data processing that allows us to let some trains go through because they're not having any issues, and stop other trains that seem to be something that needs to be investigated. So again, we're heavily focused right now from an initiative perspective on trying to address situations in which today we physically stop a train, and we want to have the data to be able to know whether that was a good decision or not a good decision, and how to help the folks making those decisions be able to be feel safer about their decision that they make.
So again, another case of sensors on the train in multiple ways. In this case, heat sensor, I presume, among others, on the brakes themselves.
Yeah, and one of the things that I talked about this earlier about the fact that when you've got someone and been working for the railroad for 40 years. I mean, we got people 50 years plus that have been working for the railroad. So if somebody has been working for the railroad for a long time, have a really good sense of what needs to be done. They've done it so often.
Mm-hmm.
We have human characteristics too, right? Decision making isn't void of whether I'm a risk taker or I'm not a risk taker, that kind of thing. So what end up happening sometimes is you end up with decisions that get made, and a different decision is made by one individual because they're not a risk taker. So they might be more prone to stop trains than say someone else.
Mm-hmm.
And the data helps us to identify and normalize that. So when we start to provide them good, clean data so that they can make these decisions, we start to see those two come closer together. So now we're making stop decisions, not just based on our premonition or our lack of willingness to take risk, but on hard data, hard information. So
go ahead. Sorry.
It just helps us. It helps us to just helps us to do it with some. And people do this, right? You and I do this. I mean, if we go outside to work in the yard or do something, and all we have is a weed eater, we may be out there trying to mow our backyard with a weed eater because our lawnmower is broke. Well, the same thing's true for people. If you only give them a train, and you only give them the information from the crew, and you only give them certain pieces of information, and that's what they have to make a decision on, they may be more prone to stop the train than they would if they had more data to deal with, more information to analyze. So we want to give
I saw my grandmother weed eating with scissors one time, but that's a whole different story. No, but so that's very interesting that you say that, because I can imagine you got a guy that's 50 years, guy or gal that's 50 years into the role, and there comes Kent, Mr. Computer Science, going to tell me what to do when I know much better than him. So, but then if it's presented in such a way that, look, this is complementary to your position, just to help you make that decision. Take this fact here. You may turn the risky guy the risky guy maybe get a little bit more conservative as he should, and the over conservative gal may say, you know what, we may be fine here given the metrics that I'm seeing that Kent's providing.
Yeah, and we're starting to see that. There was some resistance, early on, and but when we start to bring them into the decision making and into the fold to do the work and educate them on how it's actually done and what information we're looking at and all that, then now they've got skin in the game, and they actually become way more supportive than you would even realize when you engage them early. And you say, no, this is not, quote unquote, we're not replacing anybody. We're simply providing the information that you need to be able to make a better decision. And we want to provide you whatever that is. And you can tell us what that is. And we want to be able to provide it to you.
So in terms of the products, it seems like you're using the full suite of products, mainframe and distributed both, I presume?
We've been a mainframe shop for a long time, and yep, we're a big mainframe shop still, and we have distributed. Yes, indeed, we have a lot of distributed. Yeah.
Where do you make the distinction of when to use the mainframe and when to use distributed? Depending on use case.
Yeah, I mean, a lot of it is use case based, right? Are the consumers of that data mostly currently mainframe apps, and if they are, then why would I try to move the data away from them? I just create it right there. If most of the systems that are consuming that data are off mainframe, then maybe we would look at putting it off. Sadly enough, and of course it's just something that's always true in everything that we do. Cost is a factor, and we look at it from a cost perspective. So we're always analyzing our decisions based on cost, and we want to provide the most solid solution we can with the lowest cost that we can. So we're always analyzing that and reviewing it, and some of the decisions are made on that basis as well.
So as you move your way up the stack, you got data, then I presume you've got a suite of unified governance, whether it's ETL, data movement, whatever, tools just as well.
Yep. So we've got the structured, and then we've got the semi-structured, and we got the no structured data. We got all of that, and we have a governance team that do a tremendous job in very difficult circumstances, right? Because, I mean, when was the last time you met a developer who had a timetable given to them and they were really interested in giving anything to a data governance? I mean, they're more interested in just delivering that functionality, baby, and moving on to the next thing. And they see you in many cases as being an instrument of obstruction as opposed to a valued member of the team. But that's changing too. We're able to change that a little bit. But I'll be honest with you. That's where I'm currently sitting and where I'm at in the organization I work in. That's an extremely difficult task. For whatever reasons, data modelers and governance folks seem to always have to give a reason for why they exist and what it is they're doing. And then on the top of that, now you've got DBAs that are experts in data. They seem to, again, have to justify why they exist and what they're trying to do for the organization and why they're a valid member. If you just looked at a piece of data versus a piece of code, like I was saying before, I was talking to Lim before we started talking, and I find it interesting that in some cases I'm looking at data that's the same age as the development team I'm working with. In other words, the developers are in their 20s and the data is 20 years old. That data is just as valid structurally and from a governance perspective now as it was 20 years ago. Now, it may not be organized properly for some of the new features and functions that we need to be able to develop. And its value to the organization may not be as much as it was when it was first created. Because data has a life cycle, right? When it's created, it has a value, and like birth. And when it comes out in its birth, it's hot, and it moves through like a temperature profile from hot. When you start talking about predictive analytics and you're talking about real-time actionable analytics, as it moves further and further away from the event of its creation, it can become less valuable. Then it moves into a valued state, kind of like your grandmother and my grandmother. It moves into a valued state in which now you get these gems of real life-changing information from them, but you may have to sit and listen to them tell you the same story 28 times because they can't remember that they said it. So we're trying to figure out how to get that data into the hands of analysts who are analyzing, 10 hours a day and trying to determine how that can be leveraged to make real-time decisions, and do it in a cost-effective manner, right? I mean, everybody ran to Hadoop. Hadoop was the thing, and everybody ran there. And then, we're seeing things now where people are saying, well, it's just difficult for me to get what I need done in that particular layout, the way it's laid out. I need a different layout. I need it done a different way. It doesn't mean that Hadoop was the wrong solution. It just means it was the wrong solution for that particular function that this person's trying to solve, this particular riddle that this person's trying to solve. And so that's our goal and that's our job. I heard something from, and I knew I was going to get to talk to you today, so I kind of did some research. So I remember about 4 years ago, maybe, or maybe 5. I guess it could have been a little bit longer than that. At a World of Watson conference, I remember Jeff Jonas talking at a conference.
He's still around, yeah.
Yeah, and he talked about something, and it just fascinated me. He talked about, and I'm using a different term than he used. He used the term contextual. I'm going to use the term self-aware. Mm-hmm. If you could have data be self-aware, it knows where. He used a puzzle piece, I think. He talked about puzzles, and he talked about how this piece of information comes in, and it knows where it fits in the overall puzzle, and it fits itself in there, and it communicates with all the other data around it and all the other information around it, and makes sure that it stays valid and it stays reliable, and it does all that. I really think that's out there, way out there, but I really think that's where we need to go and eventually be. Because we talk about structured. What does that mean? Well, I can structure the data after it's in production. That can be really difficult to do. I can structure it before I have requirements. That's almost impossible. I can structure it as I get requirements, but then I've got to make major changes to it, which may cause outages as I'm delivering. I have semi-structured, but semi-structured loses a lot of value very, very quickly. And then no structure, I'm like the founder of the internet. I believe no structure isn't even data. I believe it's just information. So, considering what you do with information and when that information fits into the puzzle and when it doesn't, what to floor, what to keep, what to move through the data lifecycle and keep and continue to draw valuable insights out of. That's where we struggle, man. It's just difficult.
Mm-hmm.
It's
I get
that stuff that we started a few years ago. I mean, BNSF was waterfall until not too long ago. Waterfall development. Well, Agile's been around a long, long time, and so has Scrum. It's been around a long, long time. But those things, if you stay in that for very long, it changes the way your mind works. Because now, the longest thing that you can develop is an epic. And if an epic takes you more than 2 weeks to deliver, people are freaking out. Well, data issues and things that you're trying to solve with data, you can't do them overnight. You can't just do it quickly. It in some cases it takes a lot of effort, but the value can be unbelievable. But it takes a lot of time. It takes effort, and you don't just get instantly gratified because you may have to do a lot of building, a lot of resettling. You may have to do an awful lot of remapping. You may have to throw some things away and go in a different direction. You may have to pull pieces from all kinds of different sources that have have very difficult ways of putting that data together and making any sense out of it. And it's worth it, but getting people to say, okay, yeah, you can spend X, Y, Z dollars over here, and you may not see anything for it for the next several years. When they come out of that Scrum methodology, they're like, okay, I'm paying you X, Y, Z dollars, and I expect to see results in 2 weeks. It just doesn't work like that.
Well, for the listeners, who Kent is referring to is Jeff Jonas. We have had him on the podcast sometime before, and he is with Sensing, and the term that I use is typically entity resolution. But to your point, there's no question that data is certainly the new oil, but the better you're able to extract it, cleanse it, have one source of the truth, and the faster you're able to do that, the more you're going to win, right? That's why we often say there's no AI without IA, information architecture, because you got to get that right. But one more question, and then I want to go through a quick lightning round to finish up, and that's just where we get to learn a little bit about Kent. It's a very popular set of questions, if you will. People usually stay around for this. But anything that we missed that you'd like, so I'm going to have some fun with you, man. So anything that we missed, or, where can people find what you're working on? Is LinkedIn the best place to get in contact with you if they hear something and want to ask some questions?
Well, that's another thing. We try to keep things at that we're working on at the railroad, especially. We try to keep it pretty close to the best. So I don't really publish much out there now. I do have a blog that I work on a website where we're Enterprise DB2, where we post a lot of DB2 tips and things like that for DB2 DBAs and helpful things that they can use. So I would say that place. LinkedIn, if I'm going to say something out there with regards to data, that's probably where I'm going to say it. But
what's the DB2 tips blog or location?
EnterpriseDB2.com. EnterpriseDB2.com.
All right, got it. We'll put it in the show notes.
And
all right, any others?
Well, you can always buy one of the books on DB2, either 11.1 or 10.1, 10.5. Sure, you can buy one of those. It gets a lot of information in it. We're working on what I would call an advanced topic DB2 DBA for DB2 DBAs for DB2 for 11.5, and at IDUG next year we're going to teach an advanced only topic. So we're going to teach blue and pure scale advanced topics at IDUG. So if you're really interested, and I want to tell you this, I'm extremely excited about blue. We've been using it for years. Of course, I'm an evangelist for pure scale. I shouldn't say that I think more highly of blue than I do pure scale. I don't, but I really like pure scale. I like the cluster. I like the savings that we have for running a shared resource like a pure scale cluster. I like the ability to be able to quickly and easily scale and not have to buy way up front. I can buy as I go. I can plug in members and continue to expand my compute capacity for DB2. I like the folks that are developing it and working on it. There's some of the smartest people in the industry, and I'm talking about Kerry, and I'm talking about Lamb. I'm talking about the whole team up there. But blue, I'm telling you, man, I got a 7.4 billion row table. It's moving toward 10 by the time by the end of this year. By the first of next year, it'll be probably closer to 15 or 20 billion with a B. I'm an old DBA man. I used to have this fight all the time with people like Akira on the mainframe. He said, if you've got something in memory that's been sitting there longer than four nanoseconds, it's been there too long. And now we pin everything in the world in memory, and and I can't believe I'm dealing with a 20 billion row table in what I would call a transactional based system. It's got a UI in front of it. They want sub-second response time on this UI. So when I tell you, you can have a many billion row table in blue, and from a UI you can get sub-second response time. You try that with some other technology, and you can compress the ever-loving crap out of it. And now with indexing, and some new ingest stuff coming down the pike later on that IBM's developing now, it's going to be the place to be. So.
Man, that's a fantastic. I couldn't have said it any better. Thank you for that. That makes up for the ribbing that I got on stage right there.
Well, let's don't bring up ADE, okay? Let's stay off of ADE for now.
But what Kent refers to for those listeners, blue is an in-memory column store, and pure scale is the high availability cluster for DB2. Well, thank you very much. Hey, I got to get the lightning round in. All right, you ready? I'll just throw these out. You can riddle off questions. All right. Okay. You said you played ball. You said you played ball in college. What position you play?
I played left field.
Left field. Was it college? You didn't say college. But you played ball.
It was college.
Left field. Where'd you play at?
Mississippi College.
Mississippi College.
Left field.
What was your batting average?
Oh Lord, I have no idea.
Well, you should make it up. Say it's like 380 or something.
Oh, see, it's 397. Hey, baby, and I had 28 home runs. Yeah, no, I wasn't that impressive.
So left field, great. That's it. And didn't do any minor league, huh?
No, my dad played pro ball. My dad had a 277 batting average. Played 8 years in the pros. One season he was 8-1 pitching. He played every position in the pros except one. He didn't play catcher.
I didn't know that. What's your dad's name? Bobby Collins.
Oh. And he signed right out of high school. $500 signing bonus, and then he got $5,000 for making the AA Farm Club.
Nice. How many years did he play?
He played 8 years. 8 years.
That's a good career. That's a good career for.
With the Korean War in the middle, so he spent 22 months in Korea. So.
Unfortunately, that's when they didn't make quite the amount of money they make today, like a $400 million signing bonus for Trout, or signing for Trout.
Yeah.
So, alcoholic beverage of choice?
Drambuie.
What the hell? I expected from you like a Budweiser or something.
No, I'm not a big drinker. I don't. No. I mean, when I go to conferences every now and then, I'll have some wine or whatever. But I'm not a big alcohol consumer. But a friend of mine introduced me to Drambuie a few years ago as reading a book and sipping, and so it's a it's a special family recipe, believe it or not, and I think it's unknown, but it tastes good. It's real sweet,
I have to look
honey
that up,
tasting.
man. That's a new one on me. All right. So what are you most proud of?
My children and my wife.
That's an easy one, right?
Yeah.
Tell me, here's a good one. This is just for you. Tell me what's true that almost nobody agrees with you on.
Wow. Tell me something.
Tell me something that's true.
That DB2 is the fastest database in the world.
Nobody agree. I agree with you.
Yeah, well, it's a little bit of a favoritism there, but in
Yeah.
the general crowd,
Okay.
and I've got some guys that are ACEs with Oracle Corporation, and so and by the way, we used to sit side by side, and when I was working at I2 Technologies, and that's all I did was TPC benchmarks, and I beat his butt every time, every single solitary time.
Love it. I love
Yeah.
it. We're keeping that one in. All right. Fantastic. If we were to finish the interview, you step outside, you find a lottery ticket, you got $10 million. What are you going to do?
I'm gonna cash it in and go to work tomorrow, just like I always have.
Really? You can still go to work, same thing, no changes.
I won't change nothing immediately. I might change something in a year or two, maybe. I might look at it. Usually, when you do things at the spur of the moment, you do them without thinking. A lot of times it don't come out very well. So I would process it very well. I probably give most of it to charity. I'd probably think about it a lot and how I could use it. And yeah.
Fantastic. So what do you do in your free time? What do you work towards?
Well, I hang out at the lake with my wife. Look at one day buying a boat. I've never owned a boat. Look at buying a boat one day and just cruising around at night, watching the sunset on the lake. I play with my two grandkids as much as I possibly can. But to be straight up and honest with you, I work 85 hours a week. I love everything about technology. So I write Apple apps. I write Android apps. I'm working on a Java website right now. I like to look at different Java frameworks. I try to stay as relevant as I can, and I try to stay as up to date. I've probably looked at 54 different database technologies. I consider myself, I get accused, even at BNSF all the time, of working for IBM. I have. I want to tell you something, Al. I have never ever worked for IBM. I've never taken a penny from IBM. I've never worked for IBM. I've never been employed by IBM. But if someone wants to try to discredit me at my current employer, that's one of the very first things they say. Well, don't go talk to that guy because he bleeds blue. The truth of the matter is, I'll tell you
more and more.
I'll tell you point blank. If I find something wrong with the technology, it doesn't matter who the vendor is. I will point blank point it out and talk about it. I'm a technologist.
Hey, I'm a testament to that. I know that. Even on stage at a conference, you would say something. I know it.
But I believe this, right? I think we should all be that. We should all look at the technologies. We should understand them. We should understand how they work. And if they're architected correctly, then we know we can work with the vendor to make it to where it works for us. But if it's bad technology, if it's architected wrong, it's going to eventually hit some snag that it's not going to be able to go beyond. So, and most of the stuff that I see with IBM, I'm not crazy about all the name changes. I mean, IBM gets a lot of rub for InfoSphere and Tivoli and changing the names of every freaking thing. Even my favorite thing is DB2 with a lower D now.
Lower B.
Yeah, B. Yeah, but and I will say this: I remember under Janet Perna, man, we used to go after these other vendors. The vendor that starts with an O and the vendor that starts with an M and some of the rest of these vendors. We used to go after them, man. You want to say this publicly? I can prove you wrong. I can prove you wrong in no time. I can prove you wrong. and I kind of had this conversation not too long ago with someone at BNSF who will remain nameless. And he challenged me, and so I'm actually going to do this in the next week or so. I told him he could take Cassandra as an example, and he could build whatever he wants to build in Cassandra, and he could try to ingest data as fast as he could possibly ingest it on the same platform. I'll take DB2, I'll put it on that exact same platform, and I will meet or beat whatever his ingest rate is.
All right, you're going to have to tell me the results of that so we can post it on the podcast after you complete it.
Okay, I'll do that.
Fantastic.
Because they take that's what we have, right? The minefield that we live in right now. If you named a piece of software, or you named a vendor, I'd probably say, well, that company's been here at BNSF, or we run something from them at BNSF today.
Mm-hmm.
We have it. I mean, that's the problem, right? There's 84 database technologies out there with 0.3% of the market or whatever. And there's all of these, I just before I came on with you, I looked at my email. I had 6 or 7 emails, and every one of them start out with, "Have you thought about this?" And we're the #1 company in the world that does this, and you need this, and if you don't do this, you won't be complete. And I'm like, come on, man, give me a break. It's a minefield out there, a huge minefield, and people are probably investing hundreds of thousands, if not millions of dollars, and getting absolutely no results in some cases. So picking the right technology and picking the right company couldn't be more important today. It couldn't be more important today. It's at the top of the list.
So yeah, I agree. Thank you for that. That's one reason I'm still here at IBM, to be honest with you. But let's. How do you do all these Google apps? You do Android apps or Apple apps. How do you learn? I mean, how do you find out that time to learn? And is there a secret to your learning? Any cheats that you have? Because there's so much stuff out there. How do you get right to the point and are able to advance your knowledge so quickly?
So read, ask questions, talk to people who do it for a living already. Stay socially aware, with people who are writing apps today. Listen to blogs, look at blogs, listen to podcasts like yours. I mean, you can't. There's so much stuff out there. I think I could do open heart surgery next week if I just spent enough time. I'm being a little facetious here, but there's so much information out there that if you're hurting for information or you're starving for information, then I think you have much bigger problems than you need probably to see a psychiatrist or something, because there's just so much stuff out there. Now figuring out which ones are right versus which ones are wrong and all that, that's a different issue. But I mean, I could go out there tomorrow and Google and I did this not too long ago. So I had this customer that wanted to be able to read a barcode from the phone and put it on their website. So I go out there and look, and not only do I find 2 or 3 people already doing it, but I also find code that they're willing to give me for me to do it also. So, I mean, you can have done nothing in this area, but you can become pretty knowledgeable quickly. And I want to encourage people, don't worry about looking funny or whatever. If it's something you want to do and it's something that you think would be fun and exciting in technology, go do it. If you fail, get back up and do it again. I mean, come on. I think.
Last question.
Go ahead.
Go ahead. You think what?
I was watching Jeff. We talked about Jeff Jonas earlier. I actually somebody was interviewing him, and one of the first things she asked him one of those questions, lightning round things like you just said. He said, "Well, what most people don't know is my first company I bankrupted." So I mean that's what I'm saying, right? People who are successful or who are out there on the edge and they're trying to do something new and do something different, they're going to fail. I mean, you find me somebody that's never failed in data, and I find you somebody that ain't doing nothing, and you shouldn't pay them.
I don't disagree. I mean, failure. A lot of people don't like to hear this, or I said that to somebody the other day, and they said, no, everybody says that, but it's not true. I said it's absolutely true. Failure leads to success. That's the bottom line. You can maybe fail fast. I get that, but you got to fail. Hey, so what's last question, man? What's next for you? What's next on the horizon?
Another book, 11.5 book. We were just talking about that. We're doing an advanced book. We're working on that now.
Good.
We're going to do some comparison studies of DBMSs. We're going to start with Cassandra and DB2. Going to do that in the next few weeks. We're going to finish that data pipeline by the end of July, or at least the initial framework for it. That's what I like about. As a matter of fact, I thought about this, Al, because you asked me this on stage at IDUG. You said, "What do you do for a living?" It's so hard to describe. But what I was going to say is like today, right? I walked into the building and SAP had crashed, so that was the first notice I received. So I got that one, and so I was talking to somebody and say, "Okay, well, when did this happen?" And then I'm writing a store procedure for a DevOps function, so I'm writing that, and then somebody wanted to have a view written to extract some data, and they didn't know how to write it. They wanted to know if I would be willing to write it for them, and I said sure. So they sent that to me, and then I did 7 or 8 GIS requests where I was creating spatial objects for 4 or 5 different groups within the railroad. And then the manager wanted to talk to me about a deployment that had taken place and how they could streamline the deployment. And so I went into a meeting with him and talked about that. And I never know from moment to moment what's going to be coming. I turn my monitor on and my laptop on, and I might have 6 or 7 Skype conversations going on at the exact same time, where everybody's asking, "Where's this data?" or "How would you do this?" or "How could you do that?" I absolutely love that. I love problem solving, and I love creating something brand spanking new. So my problem with that is in IT, those are 2 different areas usually. If you're a great problem solver and you love creating something brand new, you're in 2 totally different departments, because that's just the way it works. And I say, no, I don't want that. I want to be in one, and I want to do both, and I want to do them both. I mean, if something critical is causing trains to stop, I want you to be the first one called, so that I can do root cause analysis. And if I was telling young people out there listening to your podcast something you cannot learn from the internet and no one can ever teach you, it's how to do root cause analysis. The only way you can do it is to do it. There ain't no other way.
Hands-on experience.
Yep.
All right, my friend, you are a champion. I appreciate you being with us today. I know that the folks that are listening are going to take a ton from this podcast. Always, I feel like we could just, I know you don't drink a beer, but I'll drink for you. And
now wait a minute. I didn't say I wouldn't drink a beer.
Oh, okay,
I just don't do that very often. But yeah.
Well, we can continue on forever. So thank you so much. I mean, that's a sign of a great interviewee. So thank you, Kent. I appreciate everything you bring to the table here. You're a good partner, certainly for IBM, but just a good partner overall. So thank you. I appreciate it. We'll put some of your contact information that you're willing to share in the show notes and the blog, the blog as well. Thank you so much. And anything else? I'll give you the last word.
I love talking with you, Al, and I appreciate you inviting me. It was really a privilege.
All right. Thank you so much. For everybody out there, talk to you next time.
Thanks for listening to the Making Data Simple podcast, where we make data fun. Be sure to visit IBMBigDataHub.com/podcasts to access the show notes and uncover even more great episodes. Remember, the views expressed here are those of the host and its guests, and do not necessarily represent the views of IBM. Until next time, over and out.